Okay, Algebra 2, here we go. We're going to talk about what we call infinite series. And almost any series can be considered infinite if we think about infinite being a complete set of values. It can go on and on and on and on forever. That type of thing would say it's an infinite series, that it can continue on. Now, in some cases, we want to know what the sum is of this infinite series. What would it add up to be? And in some cases, we can find that value. Other cases, we can't. This video is going to talk about those times when we can, and when we can, how do we figure out what it is? And if we can't, we just say why we can't. So let's get going here. Let's talk. I'm going to move this down just a minute. There. Let's talk about this real quick. An infinite series is any series that goes on forever. And some of the series are said to converge, meaning they're going to go towards one location, while others are said to diverge, which means they're going to continuously get larger and larger further apart, that type of stuff. So let's look at this. Okay, so converge, meaning to approach a single value. Now, mathematically, what this means to us is a series is said to converge if the series is geometric and the absolute value of the common ratio is less than 1. Well, that's important. It has to be the absolute value of the common ratio. So this will work whether they're positive common ratios or negative common ratios, as long as the value of it is less than 1. Okay, so what does diverge mean? Diverge, meaning to get further apart or not approach a single value. And if I wanted to look for a series, I would say a series is said to diverge if the series does not converge. So in other words, if it's not a geometric series in which the common ratio is less than 1, it's going to diverge. So let's see if we can do a few of these problems. What I would recommend you do is take a quick look, pause the video, take a quick look, see if you can come up with an answer on whether or not you think these converge or diverge. Okay, so you're back. So here's what I do. I'm going to do the 3 easy ones first, and then I'll come back and look at the harder ones. And when I talk about easy and hard, I'm talking about the fact that, hey, over here, they told me what the common ratio was. Remember, in the sigma notation, the thing with the exponent is the part that has the as the common ratio. So when I look at the top one, my common ratio is 2/3, negative 2/3. Absolute value of a negative 2/3 is 2/3, which is less than 1. So we would say that this one will converge. For the second one down here, I notice that the R is a negative 2. Absolute value of a negative 2 is a positive 2, which means I have a value greater than 1. So this one is going to diverge. The third one here, the R is 1/3. That is a positive number, and I see it's less than 1. So this is a converge. So those are easy when they're giving you the R. These other 3 problems here on the left, notice they don't give us the R. We have to figure that out. Now the great thing about this is we can figure out the R in many ways. I could take my second term here and divide it by this first term, or I could take my third term and divide it by the second term, or I could take my fourth term and divide it by the third term. It doesn't matter which one I do, I just need to do it. So I'm going to take the negative 8/5 and divide that by a negative 2. Now when I divide fractions, it means I have a negative 8/5 times a negative 1/2. Well, now I notice when I do that, the negatives will cancel. 2 goes into 8 4 times, so I'm left with 4/5 as my common ratio. Well, that's a number less than 1, so this one is going to converge. Okay, so now the second one there, I've got a negative 2500 divided by 12500. And I notice right away I can divide both of them by 100, I get to that, and I notice that 25 goes into 125 1/5 times, so I got a negative 1/5. Absolute value of that would be a positive 1/5. So again, we have another one that converges. And the next one, -1 to 2. So I would take the 2 and divide it by -1, or I could have taken the -4 and divided it by 2. Either way, I get a -2 for my common ratio. Well, now I have a value, when I look at this, that is greater than a +1, because I look at the absolute value of the -2. So this one's going to diverge. So on the assignment, one of the first things you got to do is just figure out, is it a converging or a diverging geometric series? Now, after you do that, you're going to get something like this that says, evaluate each geometric series described. Well, what that really means is, evaluate each geometric series that would have an infinite sum. In other words, I can only do these if they converge. Evaluate just means to find the sum. In this particular case. So we have to find the sum. So we can only find the ones that converge. So I can do this one here. I'm going to clone it, and I'm going to throw it down here at the bottom. I can do this one here, so I'm going to clone it, and I'm going to throw it down to the bottom. I can do this one here, so I'm going to clone it and throw it down to the bottom. And I can do this one here, and I can clone it, and again, throw it down to the bottom. Okay, so these are the 4 problems that we have that we can do. Now, how do I figure out what this infinite sum is? I could take the fact that I know it's a geometric series, so I could use the formula for the sum of a geometric series. You know, the S of n equals a sub 1 minus a sub 1 times r to the n over 1 minus r. I can do this. I can use this formula. Now, here's a small problem with the formula. Let me slide these out of the way. This part right here, as I raise it to very, very large numbers, let's see what happens. We said this -2 one had a ratio of 4/5. This was a 4/5. What? That one's not going to work real well. Let's use this one. The r is 1/3. Okay, so now watch what happens. If I take the r and I cube it, I get 1/27. If I take the r and I raise it to the 6th power, I get 1/729. If I take the r to the 10th power, I get 1/59,049. They look like big numbers, but let's write them as decimals. This is 0.037, and on and on and on, and those 0.37s repeat. This one is 0.000137. And the next one here, I get 0.000016935. Notice what's happening. I'm getting more and more zeros as I raise the power up. So if I went to r to the 100th, and I stick that in my calculator, and I'm going to go to one of my good calculators so I can get to that big number in there. And it tells me that if I took 1/3 to the 100th power, that I would get 1.94 times 10 to the -48th power, which means I now have 47 zeros behind the decimal point before I get to that 1. So basically, if I take r and I raise it to infinity, to an extremely large number, this is going to go to 0. And if that goes to 0, when I get to very, very large numbers, it means that part right there becomes a to the 1 times 0, which means this whole thing becomes 0. So my formula becomes, what's my first term, divided by 1 minus r. So I'm going to say s to infinity is equal to a1 over 1 minus r. So as long as I know what the common ratio is, and I know the first term, I can do any one of these problems. So my problem here on the left, my s to infinity would be a negative 2 divided by 1 minus 4/5, which means a negative 2 over 1/5, which means my sum is a negative 10. This next problem down, my infinity answer would say it's 12,500 divided by 1 minus 1/5. Remember, that was the r for this one, right? Yes, 1/5. I thought that's what it was. Which means 12,500 divided by 4/5, which means 12,500 times 5/4. And I get 15,625. So when we do these problems, notice that it's so much easier than when we were doing arithmetic ones or geometric ones alone, because all I need to know is the first term and the last. So in this example over here on the right, I know the first term, I know the r, so I can just put it right into the formula and say it's a negative 2 divided by 1 minus a negative 2/3, which means I have a negative 2 divided by 5/3, which gives me a negative 6/5 as an answer. Now, if you want proof that this works, we can do that. Let me know and I'll help you out there. Okay, so let's take a look at the next one. We're in sigma notation. Let me clone this puppy so we can work it out a little better. Let us increase the size of this puppy so we can see it a little better. Okay, here we go. I need to know what the first term is, which means I need to put a 1 in there. So 4/3 times 1/3 to the 1 minus 1 power, which means I have 4/3 times 1/3 to the 0. Anything to the 0 power is 1, so this gives me 4/3 times 1, which means 4/3 is my first term. So when I go to find the sum, the infinite sum, I'm going to take 4/3 and divide it by 1 minus, well, now what was my r? My r is the number inside the 1/3, 1/3. So I get 4/3 divided by 2/3, which means 4/3 times 3/2, which means 2. When I do this, I get 2. That's going to be my sum. Okay, so we've talked this through. And since we've talked it through, we can find it. All we have to do is use that formula. Take the first term, divide it by 1 minus whatever the r is, and as long as that r is less than 1 or greater than -1, so the absolute value is that, we can use that formula for any infinite series. If it's arithmetic, we can't do it. If it's one of those nonsense ones we had on, like on that first assignment where it had the n squared or whatever, we can't do those either. Because in those cases, we keep adding more and more on. The number just keeps getting larger and larger and larger, or more negative, however you want to phrase it. But that's how we do this assignment. You're ready to go. And I just hope you noticed I left you a secret message in this video. Have a good night.